recorder. The recorder is started. All right. So today we're going to talk about parameters more because there are two different special kinds of parameters. So even though we have talked about parameters already, there are more to talk about in parameters. But before I go any further, do we have any questions about a homework assignment that is due on Wednesday? Nope. Nope. Okay. All right. So now we're going to go continue to talk about parameters. So we're not quite done, with talking about parameters. We talked about some aspects of parameters, but not all. Particularly, there are two types of parameters. One is passing an array as a parameter, and then the other one has to do with passing by reference as a parameter. Um, all right. So there are pass by reference parameters here. And then there are, the other two types. Okay, so we'll go ahead and talk about pass by reference, and then we'll talk about, passing a parameter, an array as a parameter. All right, so the best thing we can do is to illustrate using a C program first, and then we're gonna go take a look at, how the trace goes. So once again, we're gonna go to online GDB, make sure that we are using the C programming language. And this time we are going to, I don't need this part of the program, so we can get rid of that. And then we're going to have a void function, which means the function itself does not return a particular value. And it's going to take one parameter. It is of integer type. So this is the first time we use the ampersand symbol right in front of the name of the parameter, which in this case, I will call this parameter, let's say n. Okay, it doesn't really matter what the name is. And in the function, the only thing we want to do is to say n gets n plus 1. Okay. And then in main, we are going to get rid of the printf because that's also not something that we want. And instead, we have a local variable x, and then we'll say f of x as the only function call in this code. So let's go ahead and run this code and see what happens. Okay. So we'll go to debug mode. It did not compile because C does not have a pass by reference. I have to use C++. All right, one more time, debug, everything looks good. And we are going to put a breakpoint. Um, let's put a breakpoint here, okay? And then we'll put another breakpoint over here. There we go. So we start the execution of the program. So the first thing we notice is variable x, which is in main, has a value of 32,767. That is somewhat of a random value. X was never initialized, in the main function. Um, so that's basically just a random value. This is equivalent to the question mark that I usually use, when a variable does not start with a particular value. So in this case, it just turns out to be that particular value. So what we want to do is to make sure it is initialized. So in the debugger, you can do something like set var and then x equals to, and then we can give it a specific value. Let's say 42. So we can see that, the value of x is now changed to 42 because of the debugger. And then we can also double check and print x, and we also see it is just 42. So this is still in main because we can see how the green box is in main. So we're going to single step into the function f. Okay, so here we single step into function f. We can see how variable x of main is used as the argument to pass to parameter end of function f. So it is not surprising that if we take a look at n, it currently has a value of 42. Okay, because it is the parameter, after all. So we now single step, and after we single step, n should be 43. So we print n, and it is indeed 43. So this part is not surprising at all. Okay, just based on what we have talked about with parameters, this is exactly what we expect the program to do. So what is interesting is when we single step back to main, and then we ask what is x, x is actually changed to 42. So this is the new behavior that we are going to explain in today's lecture, or the first thing that we're going to explain in today's lecture is passing by reference. What we have done up to this point in all the previous classes, all those parameters are passed by value. Okay, it's called pass by value. This is the only time we see something like this, which is passed by reference. So the mechanism is, I will explain that in the trace, but the bottom line here is when we pass x as a parameter, as an argument, excuse me, as an argument to parameter n, we are not just copying the value of x to the column that is labeled n, we are actually telling function f where to find x. So all the references of n in function f, they are really just going through the references, going through a method in order to find the actual variable x of main. Okay. So do we have any questions at this point about the behavior of this program? It is a very simple program, but it illustrates the difference between passing by value versus passing by reference. In this case, it is passed by reference. If you remove the ampersand on line 9, then it becomes passed by value again. But if it is passed by value, then when we get back to line 17 of main, then variable f would still have the same value as it had before, because function f would not be changing the parameter or where the parameter is referencing, because the parameter itself actually has a column. Okay, so we'll go ahead and use this program. Okay, I will have two runs of this. The first one is without passing by reference, and then the second one is with pass by reference. And then we can see how the columns are tracked differently and how the execution of the program is also going to be quite different. So are we good so far in terms of what we are about to do? Okay, all right. So we're going to talk about pass by reference. Yep. All right, so let's go ahead and do this. Okay, we are going to put the program into an editor. Okay, so let me go start my editor. It's going to complain, and okay, so we do want to restore. Okay, there we go. And we can, eh, we'll focus on this screen. File new. All right, so we're going to focus on, we'll first do the one that we already know, which is passed by value, which also means, when we define parameter n of f, it does not have an ampersand in front of it. This is the old way of doing things. So now we just go like n gets n plus 1, and that's it. That's all what f is going to do. And then we go to main, and then this time we have int x. We will give x a particular value just so that it's not unknown, and then we'll use um, x as an argument to pass to function f's n, and then this is the entire program. Okay, so this is the first version of the program that we're going to track, and then we'll track the other one, which is using pass by reference, the second. Because this way we can truly understand the differences between passing by value versus passing by reference. So once again, this one is passed by value. Okay, we'll do the usual trick, stash it to the corner here, and then we go to our share folder, create a new spreadsheet for today, and then call it, name it after today's date, 2025, 1027. Oh, 2025, 1027. There we go. And then we'll also make another snapshot of this code and paste it directly into the spreadsheet. So this way, the spreadsheet itself has a version, has a has the code that we are um, tracing. Okay, so then we just go here, and then we just do a paste. So now the code is also here. All right, so we'll go ahead and start. Okay, we got comments, we got line number. We always start with those two columns. And then we have a precondition. There are no global variables in this program, so the precondition has nothing to say. And then we start right away on line 5 if you want. Okay, And then we get to line 6. Line 6 is the definition of a local variable. So every time we encounter something like line 6, we allocate a column with the name of the variable. So in this case, the leftmost available column is column C. We label it X. As a local variable, it starts with an unknown value. So it starts with a question mark. And then we head out to line 7. Line 7 is an assignment statement. It is referring, we want to change X. X is going to be the rightmost column that is labeled X in this case. So it's referring to column C. So we're just updating column C to a value of 42. So far it's the same stuff that we have been talking about. Then we go to line 8. Line 8 is a normal function call, so we only need a return line number this time because f is not returning a value. So we can just return to the line following the invocation, which is on line 9. But we also have to remember that we are passing a parameter. But parameter n is the same kind of parameter that we have been talking about up to this point. So we just allocate a new column n, and then in that column, we specify the value that is specified by the caller. So on the caller's side on line 8, it is using an expression which is simply x to specify the parameter value of n. So x currently has a value of 42. So 42 is the value of n to start with, like so. And are we still doing okay so far? Yep. It yeah, so it depends on basically first thing is if f has a return type that is not a void, that would be the first clue that you might need a return info instead of a return line number. The second one has to do with on line 8, do we have anything else to do after the invocation? So the answer is no, we don't have anything else to do because line 8, that is the whole thing, right? So that's why we can just use a return line number to get to line 9. Yep. All right, cool. That's a good question. So now we continue our execution in the function that is called, which is function f, starting on line 1, doesn't do a single thing. We get to line 2. So line 2 is an assignment operation. We want to compute n plus 1 first. So now we go like, okay, who is n? What is the value of n? N is the rightmost column that is labeled n. So that would be column E at this point. So column E has a value of 42. We add the 1 to the 42 to end up with a 43. And then we use the right-hand side, the value of 43, to update the left-hand side, which is also specifying the same column, which is column E. So column E is now updated to a value of 43. And then we get to line 3. So in this case, line 3 is signifying the end of the function call. So that means, oh, okay, we need to use return line number, which is here, to remind us where to continue execution. So now we just go like, okay, the next line that we need to execute is on line 9. And then after that, the two columns, in this case, column D and column E, are both unnecessary at this point because we are now at the end of a function call. So everything that we allocated for the function call itself is no longer needed. So we have an Alt Shift 5 to strike out to indicate columns D and E are now once again available. But the execution point continues onto line 9, and line 9 is a return 0 in main, and as a result, we just get to post. So in this particular program, the value of x in main, once it was changed on line 7, it never got changed again. Are we okay with that? Okay. When we updated n on line 2, it is a copy of x. Okay. That was a value that was computed based on the value of x, but nonetheless, parameter n of f has its own column, which is column E. So when we update n on line 2, it is updating column E. It had no idea that it came from column C whatsoever. So column C was left alone in this case. So you can kind of think about this as you're at a DMV, okay? You got some forms. Let's say your birth certificate, because you need to get your license or whatever, right? So when the clerk, at DMV go like, okay, I'm gonna have to make a photocopy of your birth certificate, okay? They run it through the copier, and then they take copy. They take the Xerox copy of your birth certificate, and then they might mark it up a little bit, circle your birth date and your legal name and whatnot. But none of that is on your actual birth certificate. So that's kind of what's happening when we have pass by value as a mechanism to pass um, an argument to a parameter, which is what we have been doing up to this point. Okay, so this is nothing new, but I do want to emphasize that this is what we have been doing. Are we good with that? All right. So now we're going to take a look at almost exactly the same program, and I'm going to label this as by val because it is passed by value. And then we'll use a new sheet. We'll call it by ref, which is passing by reference. So now we go back to this code over here. And where did I put it? It is in the editor, this code over here. And all I'm going to do is to put an ampersand here. So syntactically speaking, it's not much. Okay, we're just using an ampersand right in front of the name of the parameter, but the behavior of the program is now changed quite a bit. Okay, so we'll see what this little change is going to do to the program overall speaking. So we'll take out this, okay, and I think the program is simple enough that I don't really need to um, have the other one. I can use just one copy, put it into the spreadsheet, and just refer to that. Okay, so here we go. Copy to the clipboard, go to the new sheet over here, and I will paste the bitmap at exactly the same place as before, which is okay because we're going to change the column width a little bit here. Comments is not going to be really used in any way because we don't have conditions to evaluate. And then we have our typical line number, which is no big deal. So now we're going to start execution at pretty much the same place. So let me just kind of move this one closer here so we can actually see better. There we go. I think that's probably a good place. All right, so we start execution on line 5 again. Okay, line 5 is the entry point of main. It doesn't really do anything. We go to line 6. We will do exactly the same thing as last time. We're allocating the leftmost available column, which is column C in this case, for local variable x. We label it, and then we say, okay, you're going to start with an unknown value. We don't know what it is. And then we move on to line 7. Line 7 says, okay, I need to update um, something of the name X. So when we search for X, we are searching for the rightmost column that is labeled X, which in this case is column C. And we're going to change it to the value of 42, just like last time. Okay, so nothing has changed up to this point. The next line, on the other hand, is going to have some changes. So on line 8, we are still having a function call. The function call on line 8, after the function call, it really has nothing else to do. So we can use return line number. So return line number is going to be line 8. So, excuse me, line 9. So even this part does not have any changes. But what we are going to do with parameter n is going to be changed. So parameter n still needs its own column. Okay, so we allocate the next available column, which is column E in this case. But instead of evaluating x as an expression, we are going to say, hey, where can I find you, x? Okay, so x says, I am column C. I'm living in column C. So this n is now saying, oh, okay, reference to column C. This is the change from last time. In other words, parameter n of f is no longer a copy of the value of local variable x of main. It is now a reference of where to find local variable x of main. So I'm just going to pause here, okay, and see if you guys are getting the concept. Mm-hmm. So yeah, so before okay, we can take a look at the previous trace. So the previous trace is just go like, okay, whatever x has, we're gonna make a copy here. But this time we are changing the way we do it. We are basically saying, oh, okay, wait, hold on a second here. We are not evaluating x as a value anymore. We are now saying wherever we find x, we'll make a note so that F can find X also, but it becomes a reference. Okay. It's kind of like, in spy movies, when you open a mailbox, it contains the instruction of which other mailbox you need to go to retrieve something. It's kind of like that. Okay. You can look at a reference like an address, like a street address. Okay. So instead of having um, something in the mailbox, which is what you really want, okay, it is telling you where to find it. Okay. Are we good so far? All right. Years ago, I would use the reference number in a library to kind of talk about this. But since most people they don't go to the library anymore, they don't know what is a reference number, so I can't really use that as an analogy anymore. Yep. All right, so now we get to the function itself, starting on line 1, doesn't do a single thing. On line 2, this time, it takes a little bit of explanation. So that means, when you watch the video again, you might want to jot down some notes of what is happening on line 2, okay? So on line 2, on the right-hand side over here, we have a reference to n. So we have to look up n. So when we look up n, it's not difficult. It is still the rightmost column that is labeled n, which is column E. But then we go like, okay, what about the value that I'm supposed to add to 1? Column E says, I don't have the value. It says, sorry, go ahead. Say again. Column, no. Column C. Column C. So when we ask column E and said, you know, what is your value? Column E says, I don't have a value, but I know where to find it. So it's telling the program, it's telling the computer, and go like, if you want a value to add, I don't have it. Go look up column C. So now the computer go look up column C, and column C says, yep, I have a value. I have a value of 42. That is when the right-hand side, this n, is resolved to a value of 42. So now we can compute 42 plus 1. Yeah, that's easy peasy, right? You're 43. So once we have the right-hand side evaluated to a value of 43, then we have to ask the question, where am I supposed to store the 43? Oh, we're supposed to store the 43 to n. So the computer would then look up the rightmost column that is labeled n. Column n says, don't change me, okay? I'm only going to contain an address. I will tell you which column to change instead. So we are not updating column E. Instead, we are updating what column E is telling us to update. So the update is here in column C. Are we doing okay so far understanding this code here? So when a parameter is passed by reference, all the updates to the parameter is not at the column of the parameter itself. It is going to be at the column that the parameter is referencing. Are we doing okay? All right. So the time is about 9:26-ish, but I did start the recording about a minute or two late. So when you look up the actual video recording, it's probably closer to just 25 the 20 25 minutes into the recording. I'm looking up my stat here. It's actually 23 minutes. So look up 23 minutes into the video. That would be this really crucial discussion of how passing by reference works. All right, so that's line 2, and then we get to line 3. Line 3 doesn't do anything other than looking up the return line number, which is column D. Column D says, let's go back to line 9 when we are all done here. Okay, that's what we're going to do. And then after that, on line 3, we're going to deallocate column D and column E because both of those are only needed when we are in the function invocation. So both of these are now deallocated. And now we continue execution on line 9, which is a return 0. It is in main, which also means, okay, we don't have anything else to do. And there, here comes the post. Are we doing okay so far? Okay, so this is a little bit tricky, okay, because when you have a parameter that is passed by reference, it is not the column of the parameter that gets updated, it is what it refers to that gets updated. And hence the name of this type of parameter is called pass by reference. All right, so I'll give you guys a minute or so, okay, to make sure that we don't have any further questions about this really simple program before we move on to something that's a little bit more complicated. So are we good? Any questions? No questions? All right. So if there are no questions, we're going to move on to a slightly more complicated program. So we're going to increase the complexity of these programs, as we move on with the examples. So now we go back to the code that we were looking at before, which is this one. And now we're going to go like, we are going to do something wonky here. Okay, so we're going to say this and then return n minus 1. And then f is going, x equals to f of 42, or f of x here. Okay. And well, just to make it less confusing, we'll have two variables, just so that it's not as confusing. Okay, so we now have y is getting the value of f of x. There we go. All right. So this is our new program. It compiles, it runs. So that means if you really want to run it inside online GDB, you can. And that's not a bad idea. Okay, I would say, being able to run the code inside online GDB can be helpful. But at the same time, it does not always illustrate exactly what is going on. So we are going to take a look at this code and figure out by the time we get to line 18, what would be the value of x and the value of y. And I forgot one line here, which is x has to be initialized to 42. And I'm going to do the same thing inside the editor here. And we'll say x is initialized to 42. There we go. All right. So we're going to focus on online GDB right now because I can actually run it and I can actually see the value of x and y, at a certain point. So the only point I'm really concerned about is what happens by the time I get to line 19. What would be the value of x and what would be the value of y at that point? Okay, so if I were to track, okay, just mentally, and I'll write it down in the trace, in terms of tracking. So I would execute this code in my head and go like, okay, by the time we get to line 17, a local variable x of main is going to get a value of 42. When we get to line 18, we are passing x by reference to n. We know it's passed by reference because of the ampersand symbol here. So that means when I update n to be n plus 1, I'm actually updating local variable x of main from 42 to 43. So we know that by the time we get to line 19, x is going to have a value of 43. The return value, on the other hand, is n minus 1. So n at that point, which is a reference to local variable x, is already 43. 43 minus 1 is 42, so that means the return value is actually only 42. The return value is utilized in the assignment over here. So y is going to get a value of 42. Okay, so that's my prediction. Okay, x has a value of 43 when we get to line 19, and y is going to have a value of 42 by the time we get to line 19. Okay, so once we figure out, okay, I think this is what's going to happen to the program, then we can run it and actually test it. Okay, so that's the whole thing about, what I promote in my classes is you need to know what the program is supposed to do first, and then you run it to make sure that it does what you think it should be doing. Okay, so now we go ahead and turn it into debug mode. Okay, everything's good. And we just started execution. I'm not going to put it into the midpoint here. So now we are over here and we can see quite clearly that variable x of main has a value of 43. Local variable y of main has a value of 42. Okay, so nothing is surprising. Okay, the program did what I thought it would do. Okay, So now we go back to this mouse pad here. And then this time we're going to do the same thing. We're going to trace this code using a spreadsheet to find out exactly why the program behaved the way that it did. Okay, so we'll select this portion and copy to the clipboard, go to the spreadsheet, which is this one. Yep. Okay, this is the one with today's date. So I'm going to add one more sheet here. And before I go any further, we're going to paste the code over here, get rid of this part because it's not really needed. And then we are going to rename the sheet, okay, because this is what we call a post increment method. And then we'll trace it, okay? So we now can go ahead and trace it. Once again, comments doesn't really do anything. There are no conditions in this case to evaluate. So comments is just, it's just taking up a column, but doesn't really do anything. Line number, we start execution on line 6. We get to line 7. So we can now, basically we can combine line 7 and 8, okay? Because one is defining local variable x, the other one is defining local variable y. So instead of separating these into two lines, which just makes the trace look longer than it needs to, we'll just combine these two and say, okay, x and y are both allocated at the same time, and they are both, they both start with unknown values. So are we doing okay so far with this trick here? It's just a little shorthand, okay? Because otherwise, the trace is going to get longer, but without really adding any value. Okay, so that means the next line is going to be line 9. Line 9 is no big deal, okay? We know how this is going to happen. And then we get to line 10. So this time on line 10, we ultimately what we want to do is to use the right-hand side of the assignment to update the left-hand side. But I can't do it yet because I have to call function f first to figure out what is the return value of function f. So that means I have to go back to line 10 after the function call. So that means I cannot use a return line number. I have to use return info so that I can return to the same line to figure out what else do I need to do on that line. Are we good so far? Okay. So this time we use return info and we basically copy and paste the entire line 10. So y gets, except for the function call, which is the only part that is replaced by a single question mark. But we also need to allocate another column for parameter n. So parameters are not optional. Okay, they have to be allocated their own columns. So n has its own column. But because we see the ampersand here, we also understand that n is passed by reference as opposed to passed by value, which also means now we look at line 10, which is the invocation, and then we say, oh, we are using argument x to specify parameter n, which in the case of passed by reference means parameter n now needs to be a reference to wherever local variable x is. So now we look up x and go like, okay, x, where are you? X says I am in column C. So now parameter n becomes a reference to column C. So parameter n is now saying, okay, I am a reference to column C. So I'm saving the two, okay, just say reference to column C like this, okay. So it's because that's all we need is to understand that it is a reference. So once we have both of these columns set up, we can even shrink this a little bit here. Then we can continue execution on line 1. So line 1 says, okay, we don't have to do anything here. Then line 2 says the same thing as the previous example. So it looks up n and go like, okay, and what is your value? The column that is labeled n, which is column F in this case, says, I don't have a value, but I know who does. Okay, so now it says, go take a look at column C. Column C actually has the value. Column C says, I have a value of 41. So we add 1 to the 42, sorry. It has a value of 42. So 42 plus 1 is 43. And then we store the 43 back to the left-hand side of the equal, which is also n. And then n, which is the column that is labeled n, is column F. But column F says, don't overwrite me, okay? I am not the person to get the new value. Column C is. So now we update column C the same way as before. It now has a value of 43. Okay, so this part has not changed from the previous trace. What is interesting is the next line, which is line 3. So line 3 is, we know how to do, we know how to execute a return statement, which is not a big deal. So when we execute a return statement, we look at the expression of the value that we are returning, which is n minus 1, and then we ask, hey, n, what is your value? Column F, which is labeled n, says, I don't have a value, but I know who does. Column C says, I have a value of 43. So 43 is n minus 1 is 42, so the return value is 42. So once we know the value that we are returning, well, we know how to do a return. We look up the rightmost column that is labeled return info, which is this column here, copy and paste it, and then change the question mark to the value that we are returning, and remind me again, what value are we returning? 42. Very good. Okay. So now we change the question mark to a 42. And that's the extent of what we need to do with the return statement or the execution of the return statement. And then after that, we skip a line to basically say by the time we get to line 10, that is what is left for us to do on line 10. And then after this point, these two columns are no longer useful because the invocation of f is now done. So as a result, both of these columns are now deallocated, and the execution returns to line 10. But this time, by the time we get back to line 10, we know, oh, okay, we know what to do. The right-hand side of the assignment is just a value of 42. We are going to use that to update the left-hand side, which is y. We look up y. Y is column D. So column D is now updated to a value of 42. And then we move on to the next line, which is line 11. It is a return 0 in main, which basically means, oh, okay, we're all done. So do we have any questions about this particular program? Because it has elements from passing by reference, which is the new concept that we talked about today, and also some older concepts like returning a value from a function that we have already talked about. So do we have any questions about that? Nope. Okay. Are we all good? Okay. Excellent. So with that said, okay, this is pretty much the extent of how much I want to talk about passing by reference. So now we move on to yet another concept. Can we pass an array as a parameter? Because it would be kind of nice if I can tell a subroutine and go like, hey, this is the array that I want you to process, okay? And then have the function to process the array. So that's what we're going to do next, okay? And before we move to that topic, to actually have an example, I am going to illustrate where in the notes it is going to talk about passing an array by as a parameter. It is section 7 over here, okay? So that's basically how it describes how an array is passed, okay, as a parameter. Um, so it has some actual description here, okay? And the actual trace, and also the description of what is happening. So it is a little terse, okay? This portion is a little terse. So the important part is to use the lecture to help you understand what is going on when we pass an array as a parameter to a function. Okay, so let's go ahead and write a new program and based on things that we have done already. So we are going to write a new program. Okay, so we'll go ahead and say file new, and we'll write a function. Okay, so this time we're going to have bool, which is boolean, as the return type, and function f is just going to have two parameters. This first one is an array, so we have a bracket open and close bracket, and then the second one is going to be just n as an integer. All right, so right here we can kind of take a pause. When we attach open and close bracket after a name, the name of a parameter, it means, oh, okay, this parameter is special. It is an array of some kind, okay? And then in here, so inside um, function f, inside the definition of function f, we can now treat a as just any array, okay? So we can use array indexing and so on and so forth. N is just really saying how big the array is, okay? That's what n is going to do. So in this case, we are going to use a local variable called sorted, okay, because that's what we want to do is to see if the array A is already sorted in a non-decreasing order. And so when we are done, we're going to return sorted. Also, the value of sorted is going to be returned. And then in between, we just have, some additional code to figure out what we need to do here. So I'm going to use int I as a indexing variable. So we initialize I to 0, and then we say while I is less than n minus 1, then we're going to go through this loop here. And we're going to add one more thing here. We'll say, as long as it is still sorted, ni is less than n minus 1, we'll stay in the loop. What do we do in the loop? It is simply saying sorted is sorted and a bracket I is less than or equal to a bracket I plus 1. Because this is what we are really checking is whether the array is sorted in a non-decreasing manner. If it is non-decreasing, it means the following element in the array is always going to be greater than or equal to the one before. Okay, so that's what the function does. And then in main, we're going to encounter a new concept as well. Instead of initializing an array element by element, there's a quick way to do it. Okay, so the quick way to do it is to say this array, I would call that um, numbers. Okay, so numbers is the name of the array. So we can use this construct here. We'll say 2, 5, 5, 6, like so. So what this syntax on line 12 is doing is actually saving a lot of time. Okay, if I don't do it this way, it would be a lot longer. It is basically allocating 4 columns for the array called numbers and initializing that particular array with the values of 2, 5, 5, 6 at the same time. So in the trace, it'll be clear. Okay, it'll be clear how this is really handy. It just saves a lot of lines in the trace. Okay, because that's not the focus of what we really want to do in this example. Okay, and then we're gonna have a variable bool, and we'll just call that. I'll call that x here. Okay, so now x is f of numbers and n is going to be 4 because there are 4 elements in the array. So that's what we're going to do. And then we just return a 0 after that. Okay. So first of all, is this program actually going to compile and is it going to work? So we copy and paste that into online GDB. Okay. So get rid of all that, paste this in, and then we are going to change the breakpoint to right here. So that is, oh, I forgot one thing. This is actually my favorite mistake. Okay, everybody has one. This is mine. In the while loop from line 13 to line 15, did I change I? No, I did not, did I? I did not update I. In other words, the only thing I got, the variable I got, is a 0. So that means throughout this code here, it remains as 0. So if I cannot move on, if I cannot exit the loop from the first iteration, it will never get out because I never changes. Okay. So that means, oh, Tack, you just made your favorite mistake. You forgot I gets I plus 1 to increment the index, the array index. Okay. Ex exactly. So this is my favorite mistake. You will discover which one is yours because everybody has a special kind of mistake that they make all the time. Okay, this is mine. All right, that's okay. Okay, um, don't beat yourself up if you make mistakes. Okay, because that's bound to happen. The important part is how quickly can you debug your program. So with me, I know my favorite mistakes. So those will be the first thing that I check. Okay. Um, And you will probably discover your own favorite mistakes. Not so much in this class because I don't ask you to write code. So in your next class, CISP 360, you will be writing code and you will find out that, oh, okay, I keep making the same mistake over and over again. Well, guess what? It's good news because you notice that you're making the same kind of mistake over and over again. So that means when the program doesn't work, you know what to check first. So that's actually a good sign. It's not a bad sign. All right. So what we'll do is this array is in fact sorted. So that means by the time we get to return 0, x should be true. Okay, so that's what I think the program should do. And I'm just going to go through debug mode without, kind of stopping in between, just so that, we kind of speed up the whole thing. So we just say print x. It should be, it is false. All right, something is not right then. That's because I forgot to initialize sorted. Because sorted is also just like any local variable, it starts with some kind of unknown value. So if sorted was false to begin with, then it won't even go through one iteration because this is an ampersand ampersand, it is a conjunction. So that means if sorted is false to begin with, it won't even go through one iteration and it would just return false here. Okay, my mistake. Okay, so stop again. And now we go here, and then we just have to initialize the sorted to true first, okay? Because that's actually how we need it to be. So and then we debug the program again, but I have to move my breakpoint down like so. So we debug the program one more time, run the whole thing, and then we print the value of x. It is true, okay? That's very good. That's a good sign. And then we go back to mousepad and fix this one too, because I forgot to initialize sorted. It needs to be initialized to true. Okay, there we go. All right, so now we're gonna trace it. Okay, we'll go trace this code. And this time I might need to display this on the side all the time because we need the trace is gonna scroll through things. And so it might need to be, we'll see, we'll see. So we'll first copy to the clipboard and then open a new tab. Okay. And I'll just call this one is sorted because that's the whole idea of the function is to check whether the elements of an array is sorted or not. And we'll stash the code all the way out here. Okay. And then we'll go ahead and this time we do need comments because we do have a loop to go through. And there we go. And then we have our usual line number, which never needs, well, it doesn't need that much space, but we'll see. All right, so we start execution on line 13, which is the entry point. That's where main is. And then we move on to line 14. So this is what line 14 is going to do. It will do quite a few things at the same time. The first thing it will do is to allocate enough columns for the entire numbers array. So it will say, okay, I need a bunch of columns for numbers. So numbers has 4 elements. The first element starts with the value of 2. The second one starts with the value of 5, 5 again, and then 6. So that means numbers is an array with 4 elements, like so. Okay, so this is how I would designate which column is which element of numbers. So if you want it to be more visual, okay, I just pressed the wrong key. You can basically combine or merge these cells so that they become one visual cell. So when we refer to numbers, it is actually referring to all of columns C, D, E, and F, but inside we have individual elements. Now, what about the value of the elements? They are not unknown because in this case, the array is already initialized. This equal here actually means it actually means assignment. So whatever is on the right hand side, which is 2, 5, 5, 6, is used to initialize numbers or the individual elements of numbers. So in this case, 2 goes here, 5 goes here, 5 goes here, and then 6 goes here. So I'm going to pause just a little bit to make sure that we understand what line 14 is actually doing here. Are we good? Okay, so once again, it is a shorthand because if I don't do this, then I would have one line on line 14 to allocate the space, and then I need four individual lines after that to initialize one element at a time. Okay, so this is really just a nice shorthand, so I don't have to do that. Most of the time it does. Okay, it maybe there are cases where you wanted to start with one, but up to this point, we only have cases where we wanted to start with zero. Yep. hmm So this time we're going to separate and let's say line 15. Okay, we have one more variable called x is a Boolean and it is unknown to begin with. So that's column G right there. Okay. And then we move on to line 16. So we're going to have to move this one over here a little bit. So now we are on line 16. So line 16 says um, we need to give x a value of either true or false because x is a Boolean. And then the right hand side is going to give us the answer. But I can't know exactly what it is unless I call the function. So that means the first time I get to line 16, I have to call f. Okay. So this is the beginning of the important part is how do we pass numbers, which is an array, to a parameter called a in the definition of function f. So we will get the easy stuff out of the way first, which is return info. We know we need return info because when f is done, we're back to line 16 and we have some unfinished business on line 16 to finish up. So we need a return info so that we can return back to line 16 to finish up the assignment operation like that. So this part is not really changed from any other discussion about how we call a function that returns a value and then we use the value for something. And then we look at all the parameters of f. It has parameter a. It also has parameter n. None of these is quote unquote passed by reference. So parameter n is really just going to go like, oh, okay, I can see that you are using a value of 4 to specify parameter n. Okay, fine, 4 goes here. The bigger question is, what do we say about parameter a? So parameter a turns out to be something that's interesting. It is actually a reference. It is similar to passing by reference. So parameter A is really a reference to where the array starts, but it only knows where it starts. So can someone tell me, looking at the trace here, what is the first column that belongs to the array that we call numbers? Column C, very good. So A is actually a reference to column C. Even though it does not look like passing by reference, okay, we don't see an ampersand here, it is actually doing that. It is only giving us where to find the array. Are we good so far? So this is a really tricky part, right? Because we are not actually making a copy of the array and then stash the copy over here. We are just telling the subroutine, the function, oh, if you want array A, this is the column that belongs to array A, but it doesn't even tell the function of where it ends. It doesn't even tell the function that it has 4 elements. It takes another argument or another parameter n to indicate that, okay, it only has 4 elements. Don't go beyond that. Okay. So this is important in C++ programming, particularly because many other scripting languages would actually pass the array with the number of elements along with it without needing an extra parameter n just to indicate the length of the array. But in C and C++, that has to be passed explicitly. All right, so now we get into the function. Okay, line 1 doesn't do a single thing. Line 2 says, oh, we have a local variable called sorted. So that means, okay, we need another column then. So now we need a column called sorted, which is a local variable of f. It starts with an unknown value, at least at this point. We also have I, okay, on line 3. So if you want to separate those two, that's fine. If you want to combine lines 2 and 3 into one, that's fine as well. But the bottom line is, oh, okay, we just need another column for I, which is also starting with an unknown value because it is also a local variable. Okay, cool. And now we get to line 4. Line 4 says I should get a value of 0. The rightmost column that has a value that is labeled I is column L. Column L says, okay, I guess it's me that should get a value of 0. And then on line 5, no big deal. It says, whichever column that is labeled sorted, you should get a value of true. So the true goes here. And now I'm going to start a trick by moving this label, I think up to here would be good. There we go. But the problem is I can't keep track of this part anymore. So as it turns out, there's a different way to make it easier. I'm not sure whether it'll work in this case. We'll give it a try. Ah, no, it doesn't like that either. Okay, does that work? Nope. It doesn't like it. That's fine. We'll then go back to the old trick of just using a different window to track the code that we're executing. If oh, okay, that's changing the width. So we're gonna have to drag this all the way back here, and then turn this into a bitmap so that we can display that. Um, let's see. I don't know how to use the clipboard to do this part, so we're just gonna have to do it the old-fashioned way, which is taking another screenshot over here and then display the smaller window using this approach. There we go. All right, so now we are ready to continue the trace on, okay, that's line 5. So now we get to line 6. Okay, very good. So on line 6, we actually have a few things to evaluate. So we actually might need to make column a little bit wider. So column A on line 6 has to say, okay, what about sorted? Sorted is true. Okay, that's column K. So we can see column K is true right now. So we go like, okay, that's true. So now we have to evaluate the right-hand side of the conjunction, which is I still less than n minus 1? I is a 0, n is a 4. So 4 minus 1 is a 3. 0 is less than 3 is true. So now we have both sides of the conjunction being true, which means the conjunction itself is true. So we're going to increase the width of column A just a little bit and potentially move this bar down a little bit too, just so that I can see these particular values in columns. Oh, that is not good because now I have no space to scroll. That's the downside of using a smaller, a screen that has lower resolution. So I'm gonna have to shrink it just a little bit and see whether it works this way. All right. So the condition of line 6 is true. So now we move on to line 7. So this is the most important part, okay? On line 7, it is ultimately an assignment statement, which means, okay, we have to figure out what is the right-hand side. The right-hand side is a conjunction. The left-hand side of the conjunction is not too bad. It is just really sorted. So sorted is still true. So that means we have to evaluate the other side of the conjunction. So in this case, the other side of the conjunction is asking, is A bracket I less than or equal to A bracket I plus 1? So you look up column A, or you look up the column that is labeled A. It is not an array, but it is a reference to the first column of the array that we need to access. Okay, so column A is not giving you the entire array. It is just telling you, oh, by the way, the array that you want to access, it starts on column C. Are we good so far? So that's what A is saying. The bracket I is still saying, okay, but out of all the elements of A, which one do I need? Well, that depends on I. I has a value of 0 right now, so A bracket I is A bracket 0, which means we need to access element of the array that starts at column C. Let me say that one more time. I will point to the actual construct here. So a bracket I is a bracket 0 because I has a value of 0. So that part is easy. But where's a bracket 0? A says, I cannot give you the value, but I can tell you where the entire array starts. It starts at column C. Okay, so you now find the beginning of the entire thing. And then the bracket I, which is bracket 0, says, okay, of the array that starts at column C, what is the element at index 0? Oh, it's column C. It has a value of 2. All right. What about a bracket I plus 1? Kind of the same deal. Okay, the first thing is to evaluate I. I has a value of 0 at this point. 0 plus 1 is a 1. So we are really asking what is the value of a bracket 1? Okay, then you look up A again. Column A, or the column that is labeled A, says I'm not an array. I can tell you where it starts, right? So now you go like, okay, fine, tell me where the array starts. The array starts with column C. But I don't need the first element this time. I need the element with an index of 1. So you look up and go like, okay, this is the element with the index of 0. Ah, this is the element with the index of 1. It has a value of 5. So that means a bracket I evaluates to 2. A bracket I plus 1 evaluates to 5. 2 is less than or equal to 5 is true. So now, in terms of the trace, this is what we write, okay, which is really simple, but the motion to conclude that this entire thing is true is not really that simple. So now we go like, okay, we evaluate the right-hand side of the assignment, the whole thing evaluates to true. So that means sorted is updated to true, okay, even though it has a value of true, it is still updated to true. That is what happens when we execute line 7. Okay, I've moved my my cells are off a little bit. Okay, so this one really goes here, and then this one goes here. All right, I'm gonna pause, okay, and see if you guys have any questions about what we just did, because this is the core of the whole discussion at this point, is what do we do when we pass an array as a parameter, as an argument to a function, and inside the function itself, when we need to refer to elements of the array that is now passed as a parameter, how does that mechanism work? So the key is to remember the parameter is nothing more than just a reference of, the array that you are supposed to work on. I know where it starts. That's the column. That's the first column corresponding to that array. That is all the parameter can say. All right. Are we doing okay so far with that concept? All right. Excellent. So with that said, okay, we get to line 8, which is the line that I usually forget. I gets I plus 1. Okay. I gets moved on to 1. And then we get back to line 6. So when we get back to line 6, sorted is still true. I being 1 this time is less than 4 minus 1, which is 3. It's also true, okay, because 1 is less than 3. All right, cool. And then we move on to line 7 again. So once again, okay, this is just kind of me repeating what I said earlier. On line 7, what do we do? First, we evaluate sorted. It's true. And then we now evaluate the right-hand side of the ampersand ampersand. The first thing we do is a bracket I. I is now 1, so a bracket I is a bracket 1. So we ask, hey, where is the value of a bracket 1? We look up the column that is labeled A, which is column I. Okay, so column I is actually labeled A. It says, I can only tell you where to find the array. It is starting at column C. Okay, fine, column C is some clue. But then we remember, I don't need the element at index 0. According to what we have here, I equaling to 1, I need the element at index 1, which is this one here. It has a value of 5. So that means a bracket I evaluates to just 5. Are we good so far? Yeah, I is 1 at this point. Yeah, because I have to scroll a little bit, and that's why it gets a little bit harder to read. Let me see if yeah, let me see if this helps. Okay, this helps a little bit because I can now show more context. Yep. So what about the other one? The one after the less than or equal to a of I plus one. So we first evaluate I plus one. I has a value of one. One plus one is a two. So this is really saying, okay, what is the value of a bracket two? Okay, so we look up the column that is labeled A, okay, which is column I, but column I says, I'm not the actual array, but I know where to find the first column of the array that we are supposed to access. So we go like, okay, that's fine. This is the column of the beginning of the entire array that we are supposed to access. But then we also go like, okay, but which element of this array do we want? Um, two. Hmm? Yep, bracket 2 also has a value of 5. So now this evaluates to 5. This also evaluates to 5. Is 5 less than or equal to 5? Yep, that is true too. So now we just write down here, a bracket I is less than or equal to a bracket I plus 1 is also true. And then we use that value of true, which is the right-hand side of the equal, to update the variable that we are supposed to be updating, which is sorted. So that is still true. And we get to line 8, which increments I by 1. It goes from 1 to 2. And then we get back to line 6 again. So this time it is still true, right? Sorted is true. I is now 2. 2 is less than 3 is still true. Yes, go ahead. Because line 2 is not about the value of sorted. Line 2 is telling the computer and go like, we're going to need a column to track the local variable sorted. So that's why when you look at the trace on line 2, this is all it did. Okay, it allocates the leftmost available column, which at that time was column K, and it indicates that it is uninitialized, which means the value is unknown, and that's why we use a question mark. Correct. So line 5, which is row 16 of the trace, says, okay, we have an assignment operation to perform, which means, we evaluate the right-hand side, which is just the constant of true, and then we use the right-hand side value to update the variable reference on the left-hand side. And the left-hand side says, okay, we need to update sorted. Where do we find sorted? It is the rightmost column that is labeled sorted, which is column K, and that's how we update it to be true. Yeah. So there are two separate things. One is to allocate the storage that we need for the variable, and the other one is to change that storage to whatever value we need to update it to. Mhm. All right, so we're almost done. Okay, so we get back to line 6. Line 6 says it's all true. The whole condition is true, which means we have to go to line 7. So once again, this time on line 7, we say, okay, sorted is true. So now we have to evaluate the right-hand side. So the right-hand side says, okay, I need to find out what is a bracket I is 2, so a bracket I is a bracket 2. And then we ask, who is A? What do you can you show me where the array is? Array A is starts at column C, so now we know where to find the beginning of the entire array. But we don't need the entire array, we just need element 2. So we go like, this is element 0, this is element 1, this is element 2. So it has a value of 5. So a bracket I evaluates to this 5. And then we have to figure out what is a bracket I plus 1, right? So I has a value of 2. 2 plus 1 is a 3. So now we are really asking what is the value of a bracket 3. We look up the column that is labeled A. It goes like, I am not the array, but I know where to find it. So now we know, okay, this is the beginning of the entire array, but we don't need element 0. We don't need element 1. We need element 3 because that's what is inside the square bracket over here is a value of 3. So that means it has a value of 6. So now a bracket I evaluates to 5. A bracket I plus 1 evaluates to 6. 5 is less than or equal to 6 is true. So now we go back here. We say a bracket I is less than or equal to a bracket I plus 1 is true. Then we could move on to line 8. We add 1 to I goes from 2 to 3, and then we get back to line 6. When we get back to line 6, sorted is still true, but then I is now 3. N minus 1 is also 3, so I is less than n minus 1 is now false, which means the entire thing is false, and as a result, we get to line 10 at this point. Is that okay? So what do we do when we get to line 10? We just figure out, okay, the value that we're supposed to return is true, because sorted has a value of true, and that's the value that we are returning. So now we execute the return statement, which is the same thing that we have been doing for a while. We look up the rightmost return info cell, which is this one, copy and paste the whole thing, change the question mark to the value that we are returning. And by the way, what are we returning? True, that's right. Okay. And then we just make a copy of this cell, one row below, skipping one row, and then we have no use of all of these columns now. So we have 4 columns to deallocate all at the same time. We got return info, we got A, we got N, oh, 5 columns, sorry, sorted, and I. So we got 5 columns to deallocate at this point. So let me see if I can remember all of those. We got return info, we got parameter A, we got parameter N, we got local variable I, sorted actually, sorted, and then we also got local variable I. All 5 are now deallocated because they are only useful when we are in the execution of function f. Now the function f is all done. We have no use of any one of these 5 columns anymore. So that means columns H, I, J, K, L, they are all becoming available again. Okay, now not that this program has anything else that need those columns, but if it does, then all of those columns can be reused. All right, so now execution continues onto line 16, which is, oh, okay, this is really just an assignment operation now. We have to look up the column that is labeled X, okay, and update that column to true. So you look it up and go like, oh, column G is the rightmost column that is labeled X. So let's update that to the value of true. And now we are all done because line 16 is the last line before line 17. Line 17 is return 0 of main, and then we get to post. Are we doing okay so far? Okay. So we don't have enough time today to implement binary search using a function because that's actually quite a bit of work. Okay. So that's what we'll do on Wednesday. Okay. But in order to make that work a little bit easier, it is really crucial that we have a good handle on how an array can be passed as a parameter. Okay. And the key is when we pass an array as a parameter, all we are passing is where does it start? Okay. Are we good so far? All right, cool. So that pretty much ends today's lecture, because without the whole class here, the class goes a lot faster. The content goes a lot faster because without having more people to ask questions to kind of regulate the pace of the class, with only like 4 people, and you guys don't have a whole lot of questions, so we don't slow down or regulate the pace as much as when the whole class is here. So having 5 minutes remaining is okay. Yep. All right. Well, thank you for being here. Happy Monday, and I'll see you all on Wednesday. But don't forget the homework that is due on Wednesday. Yep. Yep. Same to you.